Welcome to this session on median of grouped data. Let's start with a refresher on the median in ungrouped data. You might remember that the median is the middle value of a data set when it is arranged in ascending order. Imagine lining up your classmates from shortest to tallest. The median height is the one in the middle. Now, if the total number of observations, called n, is odd, you pick the value at the position open bracket n plus 1 close bracket divided by 2. For example, if there are 11 students, the median is the sixth student in order. If n is even, the median is the average of the values at positions n divided by 2 and n divided by 2 plus 1. Looking at the frequency table of marks obtained by 100 students on the screen, each row shows a mark and how many students scored it. This kind of data is ungrouped because individual values are listed directly. Understanding this foundation is important because today we will explore how to find the median when the data is grouped, which means data is organized into intervals. Ready to dive in? Let's first see how to organize data before calculating the median. Suppose you have data about marks scored by students, but the marks are jumbled up. The first step to any statistical analysis is to arrange these marks in ascending order. Imagine sorting your exam scores from lowest to highest. On the screen, you can see a neatly arranged frequency table where the marks start from 20 and go up to 43 in ascending order. Next to each mark is the frequency. That's the number of students who scored that particular mark. For example, 6 students scored 20. 20 students scored 25. And so on. Organizing data this way helps us understand the distribution of marks and prepares us for finding measures like the median, mean, or mode. It's like organizing your bookshelf so you can quickly find the book you need. Now, with this sorted frequency table in hand, we can move towards calculating the median effectively. Now, let's explore the idea called cumulative frequency, the running total of frequencies. Imagine you have a queue, and as it grows, you keep count of the number of people up to a specific point. In terms of our frequency table, cumulative frequency tells us how many students scored marks less than or equal to a certain score. For instance, if 6 students scored 20 and 20 students scored 25, then the cumulative frequency at 25 marks is 6 plus 20, which equals 26. This means 26 students scored 25 or below. This cumulative count increases as you move up the marks. And at the highest mark, the cumulative frequency equals the total number of students, in this case, 100. Cumulative frequency is crucial for understanding the distribution of data and for calculating the median, especially when data is grouped. It's like adding up the volumes of water you pour into a jar step by step until the jar is full. Understanding this concept allows us to identify which class includes the median value when dealing with group data. Let's put these ideas into practice by finding the median from a given frequency table of 100 students' marks. Our goal is to find the middle value. Because 100 is even, the median will be the average of the 50th observation and the 51st observation when the data is arranged in ascending order. Step 1 is to find which marks correspond to these positions. We use the cumulative frequency column to locate this. Looking at the cumulative frequencies, we see that the 50th observation falls at 28 marks, and the 51st observation is at 29 marks. Therefore, to find the median, we take the average of these two values. That is, open bracket, 28 plus 29 close bracket divided by 2, which comes out to be 28.5. This means that about half the students scored less than or equal to 28.5 marks, and half scored more. Notice how cumulative frequency helped us efficiently identify these positions within the data. Understanding this example prepares you for more complex grouped data median calculations. When we deal with grouped data, things get a bit more interesting. Instead of individual data points, the data is grouped into intervals, or ranges of marks, with frequencies in each group. For example, marks from 0 to 10 form one group, 10 to 20 form another group, and so forth. The challenge here is that the middle observation, our median, may not be a precise mark. Instead, it lies somewhere inside one of these intervals. To find the median, we must first identify the median class. This is the group interval which contains the median value. How do we find this? We calculate n divided by 2, which is half the total number of observations. Then, we find the class whose cumulative frequency just exceeds this value. On screen, there is a frequency distribution for 53 students, divided into class intervals with their corresponding frequencies. Identifying the median class here is our key step towards calculating the median of grouped data. To work out the median in grouped data, we use cumulative frequencies of the less than type. This means we sum up all the frequencies of class intervals up to and including a certain upper limit. For example, the cumulative frequency for marks less than 20 includes all students who scored from 0 to 10 and from 10 to 20 marks. On the screen is a table representing cumulative frequencies for various upper class limits, such as 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. These totals let us find where our median lies by comparing them to half the total number of observations, which is n divided by 2. This approach also lays the foundation for plotting cumulative frequency graphs, or OGIVs, which visually show how data accumulates across intervals. The less than cumulative frequency method is both practical and insightful for understanding grouped data. In addition to the less than cumulative frequencies, there is another way to accumulate data called the more than type. Instead of adding frequencies from the lowest class upwards, you calculate how many values lie above or equal to a certain class. For example, how many students scored 50 or more marks? To find this, you subtract the number of students scoring less than 50 from the total. On screen, you see a table displaying cumulative frequencies from the top down. The marks start from 0 and move upwards. The more than cumulative frequency decreases as the class interval increases, unlike the less than type, which increases. Using both cumulative frequency types helps us get a complete picture of data distribution. It also provides options for various statistical analyses and graphing techniques. Understanding these will make calculating the median of grouped data more intuitive. Let's examine an actual example to find the median class in grouped data of 53 students. Our total number of observations is 53. To find the median class, first calculate n divided by 2, which is 26.5. The next step is to calculate cumulative frequencies for each class interval. Starting from the lowest class, add frequencies progressively. Once you have the cumulative frequencies, look for the class whose cumulative frequency is just greater than or equal to 26.5. Checking the data, the class 60 to 70 has a cumulative frequency of 29, which is just greater than 26.5. This means the median class is 60 to 70. Identifying the median class is a crucial step. In the next slide, we will calculate the exact median value within this class using a formula. Continuing from where we left off, we have identified the median class as 60 to 70. To find the median value inside this class, we will use the formula. Median equals the lower limit of the median class plus the fraction open bracket, n, divided by 2 minus cumulative frequency before the median class. Close bracket divided by frequency of the median class, all multiplied by the class width. We know these values. N divided by 2 is 26.5. Cumulative frequency before the median class is 22. Frequency of the median class is 7. Lower limit L is 60. Class size H is 10. Let's substitute these values. Median equals 60 plus open bracket, 26.5 minus 22. Close bracket divided by 7 close bracket, multiplied by 10. Calculating this step by step. 26.5 minus 22 is 4.5. Dividing 4.5 by 7 gives approximately 0.643. Multiplying by 10 equals 6.43. Adding to 60, we get approximately 66.43. Therefore, the median mark is roughly 66.43, indicating that about half of the students scored below this mark and half scored above. Using this formula helps us estimate the median value when exact data points inside intervals are not available. Having calculated the median as approximately 66.4, let's understand its significance. Remember, the median divides the entire data set into 2 equal halves. In this case, roughly half of the 53 students scored less than 66.4 marks, and the other half scored more. This median value gives us a sense of the central tendency of scores in the grouped data, even when exact individual marks are unknown within intervals. It's a very useful summary statistic because, unlike the mean, the median is not affected by extremely high or low scores, making it a robust indicator of typical performance. Hence, understanding cumulative frequency and applying the median formula allows us to analyze large data sets effectively, making statistics a powerful tool in data interpretation. Let's summarize the method to find the median of grouped data. First, calculate the total number of observations, n. Then, find n divided by 2. Next, construct a cumulative frequency table. This can be either less than type or more than type. Both are valid, but less than type is commonly used. Identify the median class. This is the class interval where the cumulative frequency just exceeds n divided by 2. Then, apply the median formula. Median equals the lower limit of the median class plus the fraction open bracket n divided by 2 minus cumulative frequency before the median class close bracket, divided by the frequency of the median class, multiplied by the class size. Finally, interpret the median as the middle value that divides your data into 2 halves. This gives you a central measure that is often more representative than the mean in grouped data. This process transforms raw grouped data into meaningful insights about the data's central tendency. Now it's time for you to apply what you've learned. Let's try some practice problems on finding the median of grouped data. First, you have a frequency distribution with classes from 0 to 10, 10 to 20, 20 to 30, and 30 to 40. The corresponding frequencies are 5, 8, 12, and 15. Find the median for this dataset. Second, look at a table with cumulative frequencies 10, 25, 40, 55, and 65. The total number of observations is 65. Identify the median class and calculate the median value. Third, using the information from the last problem, apply the median formula. Here, the median class is 20 to 30. The lower limit, L, is 20. The cumulative frequency before the median class, CF, is 22. The frequency, EF, is 12. The class width, AH, is 10, and the total number of observations, n, is 65. Working through these examples will strengthen your grasp on handling grouped data and finding the median accurately. Remember, practice makes perfect. An awesome mastery in statistics awaits you.